Right then, so this is well, was supposed to be an intro to event-driven design, but this was a little bit. I sort of bit off more than I could chew here. It's too big an area really for a half an hour talk, especially because my intention was to start off with some of the sort of early things people did, and then sort of work my way through time to sort of the point where people are at now. So this talk is really going to be about event sourcing. And this sort of, Martin Fowler wrote about this back in sort of 2005. And I think the whole area of event-driven design and architecture, and even perhaps event sourcing, is sort of deeply entrenched with domain-driven design, lots of architecture terminology, lots of pattern type stuff. And if you're not familiar with that sort of thing, it can be quite a big barrier to entry. What's also sort of tricky about it is that what Martin Fowler wrote back in 2005 is kind of almost, it's not what people mean by event sourcing these days, it seems to me. So we'll get into that. So if you do read this article, which is just referenced absolutely everywhere, yeah, you just take care basically. And this talk is about sort of understanding why. So if we throw away all our architectural considerations about what event sourcing is, and we just look at it as a sort of software design pattern, it really is just a pretty simple pattern that is there to save history, and kind of implicitly to persist that history. So here is a super simple ship tracking service, and this is a modified version of the example that Fowler gives. And you can kind of see here that there's a shipping object and there's a tracking service, and when the tracking service notices that a ship has arrived, it basically calls in and it sets the location to be pulled. So this way, like, the ship always has a current state of the last port it visited. So the question is, like, how can we record a history of those changes to port? Like, how can we see where the ship has been? Now there are lots of ways to do that, but the event sourcing pattern is this. So there's no significant change to this like tracking process loop, the thing that actually calls out to the ship object and says, you know, update the state. But what we have introduced is we've introduced an arrived event, okay? And that's a layer of indirection. And before we set the, we can't quite see it on this one. Let's see if I can drag it down a bit. Oh, not quite. Before we set the location, what instead we do is we now create another object, the arrived event. We set that to the ship, the port. We include the time it occurred. You know, this is information from the actual tracking service, and we insert the time it was recorded, and that's like when the object was created. And then we use this event to actually set the time, to actually set the state. In this case, it's using the event's port to set the location in the shipping object. So all it's done is introduce one layer of indirection. The ship update is still a in-place operation. This object still just has location as port, but now we have a whole ton of other objects. So let's look at let's look at the state of these two different implementations. So here we have a timeline of events. So the good ship Crux departs the port of JUXT. Then the MongoDB ship arrives at the port in the past. And then our third event is the good ship Crux arrives at another port in the future. Thinking about it, these names are perhaps, when we're talking about events, calling ports the future and the past is perhaps not a good idea. Okay, so in our simple example state, after these three events have occurred, the good ship Crux is in the port of the future, and the MongoDB ship is firmly rooted in the port of the past. If we look at what the state looks like for our objects in the event source with the pattern introduced, we've still got this state here, the latest version of what the objects look like, but we've also got an ordered list in terms of the arrival of those events. And we can see here that we've got Crux, the ship Crux at the port JUXT. This was the first event, it was at 10 o'clock. And then we've got, actually this is slightly out of order, because if this was a distributed system, these events might come in out of order, despite real time. The events in real time aren't the same. So that is pretty much it, really, for what it's doing. What we need to do, what these things are called is application state, and that's like the original sort of object state that we talked about before even introducing the pattern. And now we've got the additional state, which is the event log. So in our example, the ship objects and the application state, the event, the arrived event, depart events are the event log. So it's sort of implicit in this whole area is the fact that you actually do persist these objects, yeah. And in my experience, this is where customers perhaps take shortcuts. So the application state of your objects, right, that might be typically managed by like an ORM layer, or you might use a relational database like directly. And like we saw when we updated like the object variable, right, that they're in place changes, right? It's always a view of the current system. So whatever you use to persist your storage, you really do want to be able to have an update functionality, like be able to change a row in a database. Whereas the event log, you're never going to get the same event log twice, right? Because it's based on time. So ideally, you kind of want an append-only system. You don't have to, but if you do, then you kind of have a built-in safety that you will never overwrite a log or anything like that. And this has some real world sort of implications. So recently we've been working with a customer. They've got like 500,000 users. They're recording login events. And those events, those logins, are kind of stored in an append-only BigQuery. So this is a little bit of a conflation between their application state and their event log, because now it's super hard for them because they're using the event log and only for, I think the reasons they do that is because they want to reduce their sort of infrastructure burdens. They don't want to have multiple different systems. So you can't ask very easily if you've only got the list of all event objects, like when was the last time a user logged in? Because if you do query for a user, you get back every single event object. And you might have to aggregate them, perhaps sort them to work out which was the last one that came in, and then take that value. We've seen that we've seen that desire to simplify infrastructure elsewhere. So in another customer that uses just Kafka, Kafka is principally basically it's based around a log structure. That's like the fundamental thing of Kafka, and it does sort of provide some application state storage, but it's kind of a little bit of a bolt-on, and the desire just to use Kafka everywhere means that your application state gets wrapped up in Kafka, and then that becomes really hard to sort of get access to and do things with. So what have we got? The pattern itself has given us a full history, which is great for like auditing purposes. It's provided the state separation between history and like the present view, and because we put this layer of indirection in, and if we code to this pattern everywhere, we've got a guarantee that all changes to the application are initiated by event objects. Now that's really quite important, because those three things, when we start to reintroduce architectural considerations, let us do stuff like this. So if our application is like completely nuked, we can rebuild it from scratch. Basically, if we step through every one of those event log objects in the order that they were saved out in, we can recreate the state of our ships. We'll all know the port it was last in. It also allows us to do temporal queries. So if we wanted to find out where a ship was last week, we could replay the events up until a certain date, and the state of that object will be restored to that point in time. So that's quite cool too. The other thing that it lets us do is it lets us replay events. So perhaps events have come out of order, and you can take events off, change them around a little bit. You can perhaps transform events that are bad, or there's been some sort of change, and you can recreate your app with this like new information. This is almost like branching a timeline in some ways. So there are some pretty nice sort of everyday examples if you're a programmer, that is. So first off is like Git. So if you think of the head of your sort of Git repo as the application state, like the current view of your files, then you can think of like when you're like staging, when you're building up staging, when you're like adding stuff into, you know, editing files, adding stuff into stage. What you're actually doing up there at that point is building the event that when you commit is going to basically push onto the event log. So conceptually, at least, Git kind of works like an event sourcing system. When we check out Git, right, from an older commit, we're kind of doing a temporal query, right? We're going back in time. Conceptually, you can imagine that you replay all your commits up until that point, and there you are. And then rebasing does a very similar thing here. Like if you do a funky rebase, you start changing orders of you know, where you did your file editing, then that's like event replay. So that works quite nicely. Another example is sort of accounting, double entry bookkeeping. If your application state is the balance, your like profit and loss sheet, then all the events, the credits and debits over time, and you can like replay backwards and forwards to find out how much profit you made in a certain time. Another and final example is database restoration. So if a database chooses to implement the event sourcing pattern, and every sort of change to the underlying table structure is first written out as an event before actually being written to the table structure on the file system, then that's database, in the database world, that's called like a binary log. So what happens is that you basically back up every night or every week. You get a snapshot of the application state. And from that point onwards, you can replay the binary log to any point in time that you wish. So yeah, that's another really nice example of this kind of pattern in action. So Fowler wrote that the fundamental idea of event sourcing is that ensuring every change state of an application is captured in an event object, and that these event objects are stored in a sequence for as long as the application lives. So I've slightly modified that to include every internal change. And this is where things get a little bit interesting and perhaps confusing to the first time reader. So we come on to something called command sourcing. So let's just talk a little bit about some definitions. So a command is something that you're going to request to happen in the future. Whether it includes a response is kind of up for debate. Back in the day, like a command shouldn't have returned a response, but these days it perhaps will, or just say command submitted success. An event is something that has just happened. It's a state change. It will never include a response. And yeah, they're quite simple concepts, easy to understand. So where it perhaps gets a little confusing is that Fowler talks about events and domain events, and they include both commands and events. So we'll see that in kind of action. So the command sourcing pattern is exactly the same as the event sourcing pattern. When a command comes into a system, you do the same thing. You create an event immediately, and then you use that event to actually run the command rather than just doing it directly. So now you have like a command log almost, and all the events for all the commands. So on the left here is Fowler's like kind of original example, and on the right is like the updated example I put together for this talk. You can see here that like the tracking service has got it's like the language is imperative. Yeah, he's basically saying record arrival, and then he's created a ship event, and it's got the same stuff. It's got like the time that it was created. It's got the ship and the port. And also, it's got a process, and that's the thing that goes off and makes the actual sort of state change. And you can see that. You can see that here. When record arrival comes in, we create a new object, and then we call process on that new object. And that process is basically defined for each one of these types of events. And this one is just setting the ship location to port. Whereas if we contrast that to my updated example, we're using the past tense now. We're talking about state changes. We've got arrived event, and in this object, we don't have process, right? So arrival event with a process versus arrived event without that thing, right? So this is command sourcing. You know, rewrite event to command in your head here, and this is what's understood as event sourcing. So in Fowler's talk, article, he goes on to sort of say, what are the problems? And a lot of these problems are kind of due to command sourcing rather than event sourcing. So let's say that one of the things he talks about is external systems and what things will go wrong when the most often thing you might want to do is like replay events or commands. If those things have got side effects, then you're going to start generating like behavior that you perhaps don't want. Let's say, for example, that when a ship arrives, we also launch some fireworks. If you're using the command event, right, and that process is defined like this, every time you restore your app, you're going to launch 1,000 fireworks. And that is something that you probably want to avoid. So the way that Fowler talks about how you might solve that problem is by encapsulating your calls out to whatever launch fireworks in a gateway, and basically like letting it know whether the system is in a replay state or in a normal operating state. And that's just that's like super awkward. There's a similar thing with external queries, right? If a command is sort of defined to sort of like go off and fetch today's weather and like supplement the port information, like if it's a stormy day that knocks out your power and you like replay all the events, then all the port stuff is going to now be supplemented with the day of the replay rather than the stuff that happened at the actual time. So Fowler's solution to this is to extend that idea of a gateway, but now put a cache in and remember basically every lookup over time so that you can actually put that data back in as it should be when you do your events. So to kind of fix that, and I think the community has separated out this command and event sourcing idea. So you can combine these two patterns, okay, and you can have the tracking service write out the shipping command, which is the arrival command here, and you can have that written out to its sort of command log, and then the ship itself can also just use its internal event sourcing pattern to record all its state changes. So when it comes to restoration now, you do not have to replay all the commands. Instead, you can just replay all the events. And because the events have got all the information at the point of state change, you don't cause any of those side effects. You don't hit any of the problems that like Fowler talked about, and you get your app back up to the state that you wanted. And this is, I think, this is what people aim to do these days. So perhaps it can seem a little redundant as like why you might keep a command log, but it provides a really good audit trail of like who did what, when. It doesn't let you replay if you really need to. But one of the other things that it kind of brings is like the message bus architecture abilities. So like time and identity decoupling, i.e. like you can have multiple systems consuming commands. You can use this for like real time, for massive scaling. You get like backlog stuff, all the nice things about a message architecture when you're processing your command chain. How are we doing for time?
Yeah, you're okay.
Cool. So when you're working on these systems, there's a couple of important terms that I think are a little bit opaque at the start. That's of aggregate and of hydration. So an aggregate is basically in sort of domain-driven design, is an object that has other objects in it. The classic example is an order form with like lots of line item things. In our case, it's like the ship. But that, I think the term aggregate is somewhat overloaded. If you're working in an event sourcing system, people might call like combining like Kafka streams into one stream, an aggregate, and perhaps it isn't here. So off in like the literature, like an aggregate tends to have its own event log. So in our example, the ship having an event log, is that a good or a bad thing? If there's, say, if you've only got 6 cruise ships and there's like thousands of different events going on within the cruise ship, and you're not just tracking arrivals, you're tracking loads of other stuff as well, and ports and locations, right? Then it's probably a good idea that each ship has its own event log. But if you're like you have like 100,000 ships in like an alien fleet, and you need to track their location, then obviously having an event log for each one is probably bonkers. So you would shift the aggregate route up into the tracking service, and the tracking service would be the thing that you would probably want to have your event log in. The other term is like hydration, and this is kind of like the almost like the new name for actually like putting your state back into an object. I'm going to skip this. Yeah, but essentially, yeah, I'm going to skip that. Okay. So when is event sourcing a good fit? When you've got a rich OO model, when you have a lot of behavior that isn't CRUD. I shamelessly nicked the slide from another source. When accountability and debuggability is critical, I mean, you have a full history of absolutely everything, and you can hopefully trace everything that happens through the system. So that's really nice. When you want undo, that's a really good time to be able to use it. Competitive advantage, a lot of people kind of start mining, you know, they use it as a data source for data mining. When just the real world is event driven, it's kind of just a natural fit. And when you need something that really can scale, and then there's another pattern here that would probably be of use. There's a lot more stuff. Yeah, and there's just at the end of this, there's a whole bunch of references of, you know, pretty nice definitions and articles around this. And I think that's it. I've squeezed in.